Hi, this is TechneMoira and welcome back for another episode on my channel. And today we're going to see how I repair and restore a Technics M5 cassette deck from 1980. And I hope you'll enjoy it. So sit back with your favorite drink and maybe a snack and enjoy the video. So our next project, as you can tell, will be this Technics RS-M5 stereo cassette deck. I would estimate by its style it's late 70s, early 80s. I don't know the exact production date right now, but I'll look it up. So what can I tell about this tape recorder? The seller basically couldn't say more than the usual stuff, which is that there are a few nicks and scratches and dents, you know, like on the tape deck door here, and obviously there's a button broken, and it seems to be plastic, so yeah, we'll have to look at this. Then there are two buttons missing here for the input level settings, so that isn't too good, and there are some gouges in the metal of the front panel, you know, down here. Yeah, it's a pity, but it's not more or less than what I would expect from such an old machine. I mean, it's over 40 years old now. The one other thing that the seller told me about this machine is that it doesn't play well anymore, and obviously playing back a cassette or recording one is apparently impossible. Okay, if I read the disassembly instructions correctly, there are 3 screws I need to remove from the bottom of the cassette deck. So there's one at the top which I already removed, and then there are 2 lower, so one in the middle here and then one down there. So it turns out you can indeed release the bottom panel of the cassette deck by removing just 3 screws. Yeah. I removed the feet also, by the way, but only because I wanted to clean the bottom board of the cassette deck, because it's really rather dirty and dusty. I don't think this has been opened before, so I don't think we'll find anything messy on the inside. And talking about the inside, well, this is the first look you get when you remove the bottom panel of the cassette deck. So down here you have the main board, yeah, so with all the functions of the cassette deck, right? And you have what I suspect is like a little power supply board right here in this area, mind you, down there, deep inside, right there, is a power switch, and then this block here, you see, is actually, so this block here is actually the cassette deck itself, the mechanism, and it's hidden behind this plastic panel here, or cover I should say. So yeah, I need to be able to disassemble it a bit more, because I want to replace the electrolytics inside, something which I usually do when I refurbish or repair equipment. One of the things I always do is I always replace all the electrolytics inside. Well, you know, the fact that it's really dirty inside at least has one silver lining. It means that the cassette deck was probably never opened again after it left the production hall, the Technics production hall. So I think there will only be minimal, if any, interference inside the cassette deck, so which is actually quite good a thing. You know, it means that nobody tried to mess with the mechanism inside. When I'm disassembling the tape deck, I'm not doing it randomly, okay? I do have the service manual for the Technics, but you know, service manuals only take you that far. There are certain things that you need to figure out yourself, despite the or even if the service manual is very detailed, right? Now, one of the tips that I can give you is that before you start disassembling something, anything, take plenty of pictures, and especially of those spots that you feel will give you some trouble later on. A specific example for that is you know, the tape deck mechanism is right here, okay, so right there. And if you take a look at the back of the housing of the tape deck mechanism, you can see this kind of lever here. Yeah, right here. Now, I took a peek at the service manual. This is supposed to be the record lever. Okay, so if you press the, I guess, the record button, this lever will push down on some complicated switch on the main board. Alright, so when the time comes I need to reassemble everything, it would be nice to have a few pictures of this area, just in case, you know. Also, a good thing to take pictures of are connectors, especially connectors where many wires go to, okay, 4 or more wires. Sure, you can have a very good memory, and the color codes would certainly help you, but you know, memory can fail, especially, this is especially true with me. You know, I hate to admit it, but I had a stroke, so my memory isn't what it used to be. So yes, taking pictures and doing things in a specific order, you know, from left to right, or from A to Z, let's say, helps me a lot. when the time comes to reassemble everything. Okay, so take copious amounts of pictures. So the service manual, when you read it, you know, it shows you how to disassemble the machine. Alright, so from the bottom side to the front side and then to the inside of the machine. Okay, and you know, when they tell you to disassemble something first, even if it doesn't seem logical to you, there is a very specific reason for that. Okay, so it was the disassembly was written down by the engineers who built the tape deck. Okay, so if they tell you to disassemble it in a specific order, then you should not hesitate to do it the way they tell you to do it. Okay, so there is more than likely a very specific reason for it. Okay, so before I start unmounting the actual mechanism, which I need to do first, so my instinct was to disassemble the main board first and then the tape deck mechanism, but after reading the service manual again, they advise to disassemble the tape deck mechanism first and then only the main board. Now, while I was disassembling everything, I noticed another little, let's say, fault in the tape deck, which is that one of these switches, I mean this switch here, has been bent somewhat. I guess in the past somebody must have hit it or maybe even dropped the tape deck, so this switch here is bent to the inside, so I will need to fix this as well. And of course we will need to disassemble this row of switches because I need to repair the play switch, which is, as you can tell, broken. They look metallic, but really they are not. It's just plastic, painted plastic. Alright, I undid 6 screws from the front, you could say, the front bezel or the internal bezel of the tape deck mechanism. So theoretically, at least, I should be able to lift it out from the cabinet. Alright, so I think I discovered why I couldn't lift out the mechanism or lift it away from the case, and that's because all these wires here were probably holding it back. If you look down there, let me show you in a close-up. So down there, right there, you see, those wires go into the case here and are more than likely connected to the mechanism. So what I had to do to release those wires was to release little retainers like these. Let me show you. So little retainers like these, and the way you release them is by prying open the little tip you see here. Let's see. So the way you open up these, yeah, is by prying open the little tip here and sliding those little balls through the tip. Okay, so, and there were, I think, 4 of these to undo, and that's what I had to do to release all the wires. Okay, alright, here it goes. Let's see if that helped somewhat. Oh yeah, it did indeed. Okay, I have to be careful here. Can you see this? I think you can. Okay. Oh dear. Well, there's not much play here to there's not a lot of play here. Okay, so yeah, I think I'm on the right path to release the mechanism, but I don't want to mess things up, so give me a moment to investigate what's still holding me back, and then I'll bring you back when I found it. The desoldering gun is at 365 degrees C, by the way, just so you know. That's one wire. Obviously I don't want to burn my fingers holding the wires so close to hot desoldering gun. There you go. Okay, so all the main wires have been desoldered. Okay, I took copious amounts of pictures. So now I should be able to lift out the mechanism completely. Alright, I repositioned the cassette deck. So now, technically, I should be able to lift out the thing, unless I need to undo another wire. Okay, let me see. Ah, okay. Yeah, yes, there are 2, well actually 3 more wires that I need to undo. There is a wire here, a ground wire, right here. I don't know if you can see it, but let's see. So right there, right here, there's a ground wire still attached. So I need to release that, and also there is a couple of wires, a black and a white one, connected to the motor, which is holding me back. So, and I'm thinking, yeah, I'm thinking, let me zoom out here. So I'm thinking that I need to release this twisted pair here. And there you go. The cassette deck is gutted, as you can see. Okay, and up here is the mechanism. So yeah, basically all it takes is 6 screws and then unsoldering a number of wires. Okay, so you can see the wires I unsoldered right here. Okay, so there's well, hang on, I'll give you a better view. So there's this black and white twisted pair which goes to the motor. There's this that goes to some mechanical switch. So this orange twisted pair that goes to a mechanical switch somewhere inside the mechanism. Then there's these wires that come from the playback head. So the left and right side of the playback head. And then there's this little connected thingy here, which I suspect is some sort of power supply, maybe, to some part of the cassette deck. Yeah, it's a little connector with a brown and an orange wire. Alright, to get at the rubber band which goes to the counter, which is this little rubber band right here, okay, all you need to do really is to unscrew this little plate, you know, the little cover from away from the mechanism. It's just 3 tiny little screws you need to undo, and then you can just lift this plate away, you know, this protection plate, and that allows you to reach into the mechanism and replace the rubber belt for the counter. So yeah, I've got it all prepared now for cleaning. It's sitting on a little paper rag to soak up all the dirt, and what I'm going to do now is spray it down with WD-40 and then use a little brush, something like this, yeah, basically, or maybe something like this, okay, to brush off all the parts and to take away all the old grease and dirt and dust that might be in the mechanism, okay. And I'll also take note of where they greased the mechanism originally in the factory, and I'll place back some grease at the exact same spots, which in the main will be either lithium grease or some silicone oil, okay, something like this. Okay, I use either universal silicone oil or lithium grease. Alright, I undid the spring and 2 circlips washers from the cassette loader door mechanism. So the 2 circlips were, the big one was attached here, the small one was attached a bit higher up, past, I think, I don't remember exactly, but I think just past this lever here, and the spring was mounted on top and then caught in this hole here, and with its U shape around the base here of the plastic lever. Alright, so I took quite a bit of pictures, so I don't think that will be a problem. So what I'm going to do now is I'm going to slide out the axle on which all these plastic knobs are fitted, yeah, because I need to be able to take out this one to repair it. Alright, I'm getting ready to stop. It's rather late now, and I'm beginning to get tired, and I have some problem concentrating, so I just want to make an outro for now at least, and show you how far I've come. So the mechanism of the cassette deck is cleaned, and now it needs to dry, literally dry, and then once it's dry I can apply some grease and then mount new rubber belts and mount back the motor and such, and in the meantime I can also make a repair to the play knob, this broken knob here. I took a quick look at the other knob here, the wide knob here, and these two knobs have exactly the same width. So with a bit of luck I can use this knob as a template to make the missing part for the play button. I'm going to use the other wide button. I forgot which one it is exactly, but it doesn't matter. What matters is that this complete button has the exact shape the broken one had, and I'm going to use it as a template to cast a new button, let's say, by using part of the old one and enclosing it with the shape which I pressed out of aluminum foil around the good switch. You see there? So what I'm going to do essentially is slide in the broken knob into the mold I made with the aluminum foil, and then I will reverse it and place it into this extra little mold I made out of ordinary putty. You know, the kind of putty you can buy to fix windows and stuff. So yeah, it's just ordinary putty, but you could use clay or plasticine or any stuff like that, you know. So it's not really sticky, well, a little bit sticky, but it will never dry up, so it will stay pliable, right? So the reason why I'm using this together with the aluminum mold is because obviously the aluminum foil is very, very thin and is never going to hold the shape that we want it to have, right? So what I'm going to do is press this whole thing here, yeah, into the mold I made out of the putty. So I previously pressed the good button into the putty so that it already has more or less the shape that we need, right? With all the ridges and and the little indentations. Okay, and all we need to do now is press in the whole button into the putty, then slide it carefully out, trim away what we don't need at the top, right? And then slide it out and slide in the broken button, and then we start filling it up with some epoxy glue I'm going to mix, and I'm going to use simple transparent epoxy glue which you saw me use previously on other projects. Okay, I used this type of epoxy in fact to repair my wave deck, and if you're interested about that, just go have a look at my repair video of the wave deck. Okay, so but basically I'm using the same epoxy glue. It's fast setting, so 30 minutes or so, and then well, that should be it. That should give us a functional and somewhat similar button to the original ones. Now obviously the aluminum foil is not quite the same color and the same shine as the paint they used on the plastic, but that's okay. I mean, what we want really is to have a functional knob which looks more or less the same as the original, right? So the epoxy glue hopefully will stick as well to the broken plastic as to the aluminum foil. Okay, so the only preparation I'm going to do now is to clean the broken button, at least the broken part, with some alcohol and some clean water, and then I might rough up the broken edge a little bit with some sandpaper to increase the adherence of the glue. Alright, there you go. I carefully and gently cut away as much of the excess that I could without damaging the template or the mold. And what I'm going to do next is I'm going to press it into the putty, and once I shaped the putty around the mold, all around the mold, okay, so, I'll just extract the good button out of it, and I'll slide in the broken button to as far as it needs to go in. And once that is done, then we can start pouring the epoxy. Okay, it's going really fast now. The epoxy is already setting. I mixed it like 5 minutes ago and it's already becoming very, very sticky. Yeah, so yeah, it's curing incredibly fast. Also, you know, the temperature in here is I would say normal room temperature, well, a bit cooler maybe than usual, so it's about 18 degrees Celsius right now in here. So I read on the instructions that a temperature, any temperature between, let's say, 15 and 25 degrees Celsius is okay for the epoxy glue to set, to cure. normally. Okay, so yeah, the temperature is good, the mixture is good, I think. Granted, the surface, the bottom surface, doesn't look really nice, let's say, but hey, you know, who's going to look at the underside of the knob, right? Nobody is. The thing is that the top, or the visible part of the knob, looks okay, and that it's functional, right? So yeah, I mean, yeah, I'm quite satisfied with the look of it. Okay, it's the next day, and I think the epoxy has cured. Now it's almost 24 hours later, so let's see if we can extract what we poured from the putty shape, right? Okay. Alright, so yeah, I don't know if you can see this, but I filled it up completely with actually, after the first layer of epoxy that I poured, I didn't show you this, but I poured a second layer to fill up the whole inside, let's say, of the button with epoxy, just to make it a bit stronger. Okay, so yeah, it looks okay, and like I said, the epoxy doesn't feel tacky anymore, so I'm sure it's cured. Yeah, let's have a look. I'm curious. I'm doing this the very first time, okay, so we both discover it at the same time. Let me zoom out a little. So yeah, remember, I used the putty to keep the aluminum in shape, you know, for the pouring. Okay, here it comes. And here's the result. Yeah, it doesn't look too bad. Yeah, I need to finish this with a little bit of super glue. I'm going to stick this, the excess, let's say, of aluminum to well, to what remains of the original switch. Yeah, so there you go. That's how it looks right now. So I still need to clean it up a little bit. Yeah, but if you compare it to the original, yeah, I would say it's pretty similar. Yeah. Okay, granted, the aluminum is a bit shinier, maybe, but basically the shape is the same, and it looks okay to me, you know. So it's not perfect, obviously, but yeah, it looks okay, and it'll do exactly what it needs to do, you know. So function as a button. Yeah, it has the same size, the same width. All right, so it's identical. All right, so I measured the old belts. which were built into the, let me zoom out a little here. Okay, so I measured the old belts that were in the mechanism of the Technics. So to measure a belt, what I do is I pinch them together like this. I fold them like this, okay, and then I measure this length, okay, which is half the length of the full rubber band, and this happens to be 14 centimeters, so 140 millimeters in length. So the total length of the drive belt is 280 millimeter, okay, so 28 centimeters. The counter loop belt, when measured folded like this, yeah, measures 10.5 centimeters, so 105 millimeters, okay, so yeah, 105 millimeters. So double, that would be 21 centimeters or 210 millimeters, okay. So there you go. Those are the values of the rubber bands that were installed in the mechanism, and I have no doubts that those were in fact the original rubber bands. And then these are the replacements that I found in my stock, and that I'm going to use to mount back into the mechanism of the Technics. But before I can do that, what I'm going to do next is I'm going to grease some of the mechanical parts, especially those that slide, and some of the cogwheels of the mechanism, with either lithium grease for the sliding parts and some I always forget the name, what do you call it? Oh yeah, silicone oil for the cogwheels. Okay, so anything which rotates with some silicone oil, anything which slides or grips, yeah, with some lithium grease. The screws are unequal in length. Okay, so the two bottom screws here for the flywheel mounting base, let's say, the bottom screws are short ones like these, okay, and then the top one here, so right here, is a long one like this. Before you tighten the screws definitively, always check that the flywheel is mounted properly, is seated properly on its bottom bearing right here, that little plastic cap, okay. And you can do that by simply rotating the flywheel with your thumb, and if it feels like it's turning without scratchy noises or whatever, then and it doesn't wobble, then you are reasonably certain that it's seated well. And then you can tighten the screws. No need to go overboard tightening the screws. When they are snug, that's more than enough. Like this. Voila. So again, no need to go overboard with tightening the screws. As long as they are snug, I would almost say finger tight, it's more than enough. Okay. So there you go. The main belt is mounted over the flywheel. I don't know if, I think you can see it. Yeah, you can see it right there. Okay. So the belt is mounted on the flywheel and on the motor, on the pulley of the motor, of course. Okay. So that's how the belt should be mounted, the main drive belt. And then the belt for the counter mechanism is also mounted. Alright, so it goes to a little pulley down there. Maybe let's show it to you from another angle. So okay, so this little pulley here, and then to one of the cassette rotators here. Okay, so there you go. It's fully greased. The rubber bands are all installed. So what I need to do next is reinstall the rows of buttons here, down here, and the little cassette cradle, you know, this. And when that is done, then let's say in broad lines the mechanical part of restoring the cassette deck should be done. Voila! Everything is mounted back, well, except for the bezel, of course, which goes on top of this, the cassette loader rail, let's say. But except for that, everything else is mounted back. So there's the little protection plate here, which I mounted back off camera. It's held on with 3 screws. Let me show you. So there's 1, 2, 3 screws which hold on this little, how should I say, protection plate maybe, or bezel possibly. Either way, I mounted it back, and it protects among other things the little rubber belt which drives the counter mechanism, right? So as you see, I also mounted back the cassette cradle, okay, which hinges on the axle on which the buttons hinge as well. Okay, and it's not too complicated to mount it back. The only detail is mounting back the spring here. Yeah, so this spring makes the cradle slowly move outwards. Okay. There are 2 circlips that you need to attach as well. Okay, there's a large one right there, and a smaller one right here. This retainer clip or washer keeps the spring in place. This one, the large one, keeps the whole axle in place so that it can't move back and forth, right? So yeah, there you go. It's not too complicated to put it all back together if you keep track of all the parts and screws and what have you. Oh yes, let me give you a close-up look of the motor mounting bracket. Okay, so now this was a little bit harder to remove, especially up here. This was very stiff, so I had to work a little on it with pliers, but you know, not using brute force, but still I had to apply a bit more force to release it. So there you see how the belt is looped. Okay, the drive belt and the flywheel. Okay, so basically the whole mechanism, the whole cassette mechanism is clean, greased and mounted, reassembled I should say, and ready to be mounted back into the housing of the cassette deck. But before I can do that, I first need to recap the motherboard of the cassette deck, so that will be next. Oh dear, what have I done? Okay, so it took about 5 screws to unmount the main board, which in the end is not so difficult at all to do, but man, look at it. I mean, look at all those electrolytics. I mean, I counted those over there. There are 21 electrolytics to replace. And then on this side here, there are not much less capacitors to replace as well. So, oh dear, oh dear, oh dear. I've got a number of recapping hours ahead of me. The pleasures of recapping. Alright, about 23 capacitors are done on this side, and here they are to prove it. Now I've got 25 to replace on this side. Alright, I just finished recapping the main board, and while I was giving it a good clean, I discovered something printed on the board itself. It's fading a bit now, but it was a little bit clearer a few minutes ago. But you know, I thought before I lose track of it, the stamp on the board said 171180. So that would make this board and the whole cassette deck as leaving the factory the 17th of November 1980. Okay, the main board of the Technics cassette deck has been inspected and cleaned. I cleaned the last of the dirt off the board, removed some residual solder flux and all that, and I just used some alcohol, okay, some pure 95% alcohol and a little brush. Whoops, a little brush like this, okay, to clean off the residual dirt off the board. And there you have it. I wouldn't say it looks brand new, but it looks a whole lot better than what it was originally. So I'm going to place the board back into the case, yeah, the cabinet of the Technics. And to do that, down there you see the wire of the transformer, the main wires. In fact, the wires that go to the mains power, they need to be caught in sort of like a metallic rubberized holder, yeah. So that's a little detail you shouldn't forget. Also, if you look at the insides of the cassette deck, what you'll notice is this arm here. I don't know if you can see it. Let's see. Okay, so right there you'll notice this arm here, okay, and this arm is to action the sliding switch, which is located on the main board itself. So if you look at the main board from the side, right there, okay, you see that the head of the switch right there where I'm pushing with my little wooden stick, right? So you have to slide the main board in from the side, yeah, and make sure that the switch, the head of the sliding switch hits this lever here, the side of this lever. So you need to push it all the way to the other side, okay. It may seem like a little detail, but it's really important. If you don't get this right, then you'll have to disassemble the whole cassette deck again, just to mount back the main board. Alright, the moment has come to at least temporarily rewire the whole cassette deck. You remember that I undid the wiring that leads to the mechanical part of the cassette deck in order to well, to have it easier to work on the main board, you know, replacing the caps and everything, and to clean the mechanical side of the cassette deck as well. So, you know, I judged that it would do far less damage to just simply disconnect it, the mechanics from the main board. And this is where taking pictures of the wiring that you disconnected, in this case on a smartphone, is very handy, yeah. And that's exactly why you take pictures of the stuff that you need to reconnect, right? So, for example, like this, okay. So yeah, one of the tips that I can give you is to always make pictures of, especially of wiring that you will need to reconnect later on. Alright, I reconnected the tape deck, well, the actual mechanism, to the main board of the cassette deck. I still need to dress the leads a little bit better, but this will do for a test run, right? So yeah, I reconnected everything. I also screwed in the ground wire for the cassette deck, which is located down there, right in the corner down there. It's a black lead. I don't know if you can see this, but let me show you. So down there, right there, okay. I reconnected the ground wire because, well, you know, having a good ground is a necessity, you know, not to have any interference with the sound. Now I haven't switched it on yet. I did connect it up to my test amplifier, although one of my speakers isn't too good, but you know, for a preliminary test this will do. Now when you play a cassette, there's always going to be a little bit of what they call wow and flutter, okay? Wow and flutter. Okay, this is 1 kilohertz. You see the frequency fluctuate a little bit, okay? So with tens of hertz, maybe, you know, at best with only just a few hertz, sometimes with a bit more, but always close to the base frequency you're trying to measure, okay? Now the wow and the flutter is visible when I show you the frequency like this, okay? Much less when it's spread out. Well, you can see it here, okay? So the wow and the flutter, the wow is the change in frequency, yeah? So the lowering or the increasing of the frequency, okay? That's what they call wow. And then what you see here under and above is what they call the flutter, yeah? And basically the wow and the flutter are dependent on the mechanism of the cassette deck, right? The newer, the more precise it is, the less of those phenomenons you'll see on the screen, right? Now unfortunately, perhaps, there's always a little bit of that on a signal. I mean, it's the same problem, let's say, with record players, okay? You also have what they call wow and flutter. So, yeah, you know, it's the nature of the beast, okay? So, if you're working with a motor, and with gears and all that, and a stretchable plastic tape, you're always going to get that sort of, how should I say, signal difference, yeah, or signal deformation, okay? So you can only aim for trying to make it play as cleanly as possible. Alright, we're getting close to buttoning up the last loose ends on the cassette deck, and one of the things you might notice is that I also built a small replacement for the original incandescent light bulb lighting of the VU meters. You see there the blue LEDs I built, okay, and I in fact mounted them on a tiny little board you see down there, right? So yeah, the reason why I did it this way is because the power that comes to the LEDs is AC. I measured it, it's 6.5 volts AC. Okay, and the LEDs, which in fact are diodes basically, are mounted in opposition to each other. Okay, so one LED's cathode is connected to the anode of the other LED and vice versa. And then there's a dropper resistor of 220 ohm in series with both LEDs, and that's where the AC comes onto. Okay, I'll write you a little schematic in a moment to explain things. So then I mounted back the little covers for the selector buttons here, which are these little panels here. Okay, alright, so these slide on like that. Okay, and I also installed or reinstalled all the screws holding down the Cassettedeck mechanism to the case. I also looked around in my stash of parts, and I think I found a solution for the missing buttons. Right? So you'll remember that the buttons that were supposed to go on these potentiometers here, okay, were missing. And what I found in my stash of buttons and all that is this little plastic extension here, okay, which slides on to the shaft of the potentiometer like this. Alright, just like that. Alright, and then I found two of these buttons, you know, which have, in my opinion, the perfect shape and coloring that will fit right on to these plastic shafts, just like that. Also, I cleaned up as well as I could the front panel of the Cassettedeck. Now, as usual, I mean, I'm sure many of you, or some, at least some of you, will agree that quite often you find little paint spatters on a piece of equipment, and it was no different with this Cassettedeck, and I managed to remove, let's say, 99% of them, and I even managed to, let's say, dress up a little the nicks and dents that were in this aluminum front, okay? And I used a very fine file to file away most of the dents. Alright, so if you want to build the same kind of illumination for your VU meters, this is the schematic. Alright, so you have two LEDs, blue LEDs, mounted in opposition, okay, with a 220 ohms quarter watt resistor in series with both of them, and then connected to the AC, you know, coming through those green and yellow leads you see over there. Alright, so come on, focus, focus. So there. Okay, so that's the schematic you need to follow if you want to build in blue LEDs. 3 kilohertz. But this is in the middle of the tape. 400 Hertz. Okay, I think you get the idea. So this is what I went through with the cassette deck to set it to play exactly, or as accurately as possible, the frequencies on the calibration cassette. Alright, I inserted a fresh cassette, Sony cassette, into the cassette deck, and I played record and play together to record some music, and I also pressed the pause button. So now I'm monitoring the input levels on both channels, left and right, and I set, let's say, a level where the needles rarely go into the red. Okay, just barely go into the red. Alright, so there. This is the left channel, maybe a bit less, like this, and then the right channel, not too bad. I think the right channel is okay. Okay, so now I'm going to record about a minute of sound. Here we go. So there. We're going to wait until the tape counter measures about 70, which is about, oh, I'd say a minute and a half worth of music. So here we go. Alright, so this is the song I'm recording right now. But it might change, of course, since I'm tuned in on a local digital land radio station. Okay, the sound should be pretty good since it's digital music, so we'll see. Alright, I set the recording levels to around 6. That should be okay. I mean, you have to tweak it a little bit when you're recording. Also, what I did notice is that there is a Dolby filter in the cassette deck, and the Dolby filter is either on when you're playing, so when you're on the out position, or is on when you're on the in position. Now, like I said, I'm recording a digital radio station, so I think the sound is pretty good and doesn't need Dolby correction. But if I wanted to, I just have to flick this switch in the in position. I'm using normal ferrite cassettes, so the position here is on NOR, so normal. Okay. Yeah, I still haven't found chrome or metal cassette, I mean at a reasonable price, but I'm still looking. So there we go. We have about 4 minutes worth of music now, so let's stop and listen to parts of it. Obviously I can't let you hear the whole recording because well, you know, I don't want to get any copy strikes from YouTube, right? But I'll let you listen a few choice little parts of the music, right? So let's rewind it now. And as you can tell, the rewind works perfectly. So what I need to do now is reconnect the cassette deck to my speakers. Okay, the auto stop works as well. And we'll have a listen. Alright, I rewound the tape. Now, before I start playing some of the tape, I have to tell you that when you're recording on cassettes, any cassettes, it doesn't matter, you should always avoid playing, let's say, the first 10 seconds or so of a cassette, because you remember I told you there's always a little bit of wow and flutter on a cassette tape, right? But the ends of the tape are the ones that get most worn out and stretched. You know, every time you rewind the cassette, the ends of the tape are being stretched, and the sound quality at that part of the tape really drops quickly. So I let you hear how a stretched start of the cassette tape sounds like, and it's not pretty. So here we go. Yeah, you can tell the sound the sound is distorted and fades in and out and what have you, so it's really not pretty. But I'm going to fast forward now to a part of the tape where the sound is excellent. So here we go. Okay, okay, maybe a little bit more. Okay, there we go. So now this is how the tape would sound like, or sounds like, when it's in perfect condition and the recording went flawlessly. Yes, that's right, I'm calling. Okay, so now let's go on a little more. Wait, I want to rewind to here. Okay, so now listen to this. It is so easy. Good times, great music, it is true. Well, there you go. So you can tell the sound is really good now, and it would be even better if I recorded on a chrome or a metal cassette. I mean, this is just a normal tape, right? So this is the tape I'm using right now, which is a Sony Type 1 normal. You know, and they mean by that the bias on the tape. Yeah. Bias is an interesting notion when you record on a tape. In fact, you know, chrome and metal require a different type of bias. I will explain this in a later video, but suffice to say, the sound quality improves with a different bias, in fact. Okay, so yeah, I'm using a Sony normal cassette, and I think we can now stop the demo and say, well, it's finished. The Technics M5 has been repaired and cleaned and refurbished, and it works great. I'm really pleased with the result. So there you go. This was a restoration of the Technics M5 cassette deck, and I hope you enjoyed it. And well, thanks for watching, and see you soon for another video.